is the analysis portion of Titration 1, where we're trying to figure out the concentration of commercial vinegar. I'm having to do the results this way because when I was editing the video, I noticed that that portion didn't turn out very well. And then as I was editing the video also, I noticed that I had made some mistakes in viewing the readings. So I re-recorded the data. The initial reading for the first one wasn't exactly at 0, it was at 0.11. Final reading was 32.36. Subtract those two to get 32.25. The initial reading for the second, this reading was blurry, so it couldn't be reread. The final reading was 40.85. Subtract the 2 to get 32.30. The initial reading for the third trial was 5.21. Final reading 37.73. Subtract the 2 for 32.52. Now, the goal is to get 3 like trials, and these 3 trials were close enough to consider like trials. So if you average these 3, you get 32.36, which is the amount, that's the volume of the base titrated. So if we carry that over to the titration equation, VA-NA equals VB-NB, where VA is the volume of the acid, and each time we used 10 milliliters. The normality of the acid, the concentration, is what we don't know. The volume of the base was the average of the 3 like trials, 32.36 milliliters. And the concentration of the base was 0.13 normal. If you remember back to the video, it's printed right on the big container. So if we take 32.36, multiply it by 0.13, and divide it by 10, we get 0.4207 normal. Now, since the acetic acid is a monoprotic acid, meaning it only has one ionizable hydrogen, a single proton to donate, the multiplier here will be 1 when we go from normality to molarity. So 0.4207 times 1 gives us 0.4207. So that's our molar concentration of vinegar. Carrying that down to this calculation, we were then, if you look on the label of commercial vinegar, it's sold as a percent acetic acid. So to get that, we take the molarity, which is 0.4207 moles per liter, and we multiply it by the formula mass of acetic acid, which is 60 grams per mole. You'll notice the mole divided by mole will cancel, and we're left with grams per liter, which is the same as the denominator. The density is grams per liter. So those units cancel, and we're left with a percent. So when we take this times this divided by this, and the reason we have to double it is, if you remember from the video, I diluted the vinegar 1 to 1 so that we didn't have to use as much solution. So we have to double our final answer. When we do that, we get 4.925%. Now, most commercial vinegars, including the one that I purchased, is sold as 5%. So we're off by, if we subtract these two, we're off by 0.075 percentage points out of 5. So we take 0.075 divided by 5 times 100, and we get a 1.5% there. Pretty good. Now, the balanced equation says, look in the purpose procedure section. So if we go all, well, why is that not scrolling? We go back to the beginning, purpose and procedures, the 2 things we mixed, vinegar with sodium hydroxide. When you add an acid to a base, what happens? They get neutralized, and neutralization reactions are a form of double replacement reaction. So the H and the Na trade places. So Na's new partner is acetate, so we get sodium acetate, and H's new partner is OH. HOH is water, H2O. And it balances out as written. Okay, the dissociation equation for this acid, when the acid dissociates, you get a hydrogen ion and the negative ion. So, acetic acid dissociates into a hydrogen ion and acetate ion. And we should have a water in here, and this should be hydronium, but this simplifies out and it's easy to ignore the water. Now, the ionization constant expression, I should have it written right here, but I use it down in the next calculation. So if you remember, the dissociation constant is the concentration of the products over the concentration of the reactant. So we take the concentration of hydrogen ion times the concentration of acetate ion divided by the concentration of the original acid. Okay, now these two are equal to each other, because every time an acid molecule dissociates, you get a positive ion and a negative ion in equal concentrations. So we can let these two be X. This is given, it's calculated, and they're found in tables. And the value of this shows you that vinegar is a weak acid because the K value is very small. So X squared, these two are equal, and then the concentration of the acetic acid comes from way up here, 0.4207 molar concentration. So then if we do the math, we cross multiply, this times this equals X squared. So X squared equals 7.2486 times 10 to the negative 6th. My apologies for the sloppy handwriting. It's hard to read that squared. Then we take the square root of that to get X, and we get X equals 2.692 times 10 to the negative 3rd. Remember that X is the hydrogen ion, which is the same as the hydronium ion. So that's our first answer. The hydronium ion concentration is 2.692 times 10 to the negative 3rd molar concentration. And then to find the pH, remember the pH is the negative log of that concentration. So you just take that answer and take the log of it and make it positive. Negative of a negative is a positive, so the pH is 2.57.